Hi! Today we will learn about writing expressions with rational exponents as radicals and vice versa. Our objective is to write expressions with rational exponents as radicals and vice versa. All numbers with rational exponent can be expressed in radical form, and these are called radical expressions. Radical expressions consist of number 1, a radical sign. This is the symbol which indicates roots of the number. Next, we have the radicand. Radicand is the number inside the radical sign or the number whose roots are to be considered. And then for the third one, we have the index. This is the small number which indicates the order of the radical. It tells what root is to be found. In the radical expression, nth root of a, n is the index, a is the radicand, and this is the radical sign. So say for example, we have the cube root of 8. This is our radical sign. 8 is the radicand, and 3 is our index. The expression nth root of a is read as the nth root of a. In case n is equal to 2, the index is read as the square root. In case n is equal to 3, the index is read as the cube root. The nth root of a number is a number that is taken n times as a factor of the given radicand a. Square root, cube root, and other roots. Evolution is a process of finding one of the equal factors of a given power. One of the factors is called the root. One of the two equal roots is called square root. And one of the three equal roots is called cube root. Every positive number has two square roots. The positive, which is the principal root, and the negative root. So say for example, square root of 4. So the square root of 4 is positive and negative 2. So the positive 2 is the principal root, and then the other root is the negative root. Let's continue. Negative numbers do not have real square root. The number 0 has only one square root. So let's have some examples. Square root of 144 is equal to positive and negative 12. So this is read as the square root of 144 is positive 12 or negative 12. The index is omitted. So if the index is omitted, it is understood that the index is 2. So in square root of 144, the principal root is positive 12. Let's have another example. Square root of 25 over 64 is equal to positive 5 over 8 and negative 5 over 8. So we get the square root of both the numerator and the denominator. The principal root is positive 5/8. Another example. Square root of negative 100. Now in this case, there is no real root. Number 4. Square root of 4x squared is equal to 2x. So the principal root is positive 2x. Since 2x quantity raised to the second power is equal to 4x squared. If the radicand is a perfect square, the square root is rational. Otherwise, the root is irrational. Say for example, we have square root of 5. 5 is not a perfect square. Therefore, the square root is not rational. So it is irrational. The radicand is not a perfect square, so the root is irrational. Same with number 6 example, square root of 13. 13 is not a perfect square. That is why the root is irrational. A number is a perfect cube if it is obtained by multiplying either the positive or the negative roots by itself 3 times. Let's have some examples. Cube root of 64 is equal to 4, since 4 raised to the third power is equal to 64. Another example. Cube root of negative 125 is equal to negative 5, since negative 5 raised to the third power is equal to negative 125. Another example, we have cube root of negative 14. Now in this case, 14 is not a perfect cube, so we cannot get its exact cube root. Remember that index greater than 2 is always indicated. Say for example, we have fourth root of 16. So the fourth root of 16 is positive 2 or negative 2. Since 2 raised to the fourth power is equal to 16 and negative 2 raised to the fourth power is equal to 16. Another example. This is read as the fifth root of 243 x raised to the fifth power y raised to the 10th power is 3xy squared. Since 3xy squared quantity raised to the fifth power is equal to 243 x to the fifth power y to the 10th power. If m over n is a rational number and a is a positive real number, then a raised to m over n is equal to the nth root of a raised to m, provided that the nth root of a raised to m is a real number. So the form nth root of a raised to the m power is equal to a raised to m over n. It is called the principal nth root of a raised to m. Through this, we can write expressions with rational exponents as radicals and vice versa. So say for example, we have x raised to 1/2. So in radical form, that is the square root of x. Let's say we have x raised to 1/3. In radical form, this is the cube root of x. Another example, let's say we have a raised to 3/4. In radical form, that is the fourth root of a raised to the third power. Another one, let's say we have a raised to 2/3. So in radical form, that is the cube root of a raised to the second power. So if we will try to observe, the denominator in the rational exponent becomes the index, and the numerator is the exponent of the radicand. Let's have more examples of writing expressions with rational exponents as radicals. So let's say we have 2 raised to 1/2 in radical form. So that means we have the square root of 2. Another one, we have 3a quantity raised to 2/3. So in radical form, that is the cube root of 3a quantity raised to the second power. Let us simplify the radicand. So that means 3 raised to the second power, a raised to the second power. And this is equal to the cube root of 9a squared. So it means that 3a quantity raised to 2/3 in radical form is equal to the cube root of 9a squared. Let's have another example. We have 8a squared b quantity raised to 3/7. In radical form, this is written as the 7th root of 8a squared b quantity raised to the third power. Simplifying the radicand, we have 8 raised to the third power, a raised to 2 times 3 is 6, b raised to 1 times 3 is 3. Evaluating 8 raised to the third power. So the value of 8 raised to the third power is 512. So we have the 7th root of 512, a raised to the 6th power, b raised to the third power. This is now the radical form of the given expression 8a squared b quantity raised to 3/7. So that is how we write expressions from exponential form to radical form. This time, let's have examples of writing radicals as expressions with rational exponents. So this time, the expressions are written in radical form and we will rewrite them in exponential form. Square root of 7. So in exponential form, that is 7 raised to 1/2. Another example, we have the 4th root of 14x. In exponential form, that is quantity 14x raised to 1/4. Let's have the third example. We have the cube root of 25a raised to the 6th power, b raised to the 4th power. In exponential form, we have 25a raised to the 6th power, b raised to the 4th power, quantity raised to 1/3. We know that 25 is the same as 5 raised to the second power. So we have 5 squared, a raised to 6th power, b raised to 4th power, quantity raised to 1/3. So the given exponents, if you will try to observe, 2, 6, and 4 are all divisible by 2. So we will bring out the exponent 2 and multiply it to the outside exponent, which is 1/3. So we have 5 raised to 1 times 2, a raised to 3 times 2, and then b raised to 2 times 2, multiply by 1/3. Next. So this exponent 2, we will put it outside. So what will be, or what will remain inside the parentheses, we have 5 raised to the first power, a raised to the third power, b squared. And then quantity 1/3 times 2 from this given exponents. So therefore, this is equal to quantity 5a cubed b raised to the second power, quantity raised to 1/3 times 2 is 2/3. So this is now the exponential form of the given expression. Let's have more examples. So the instruction says write in radical form. 3 raised to 2 over 7. In radical form, we have the 7th root of 3 raised to the second power. And 3 raised to the second power is equal to 9. So this is written in radical form as the 7th root of 9. Letter B. 4x squared quantity raised to 1/3. In radical form, this is the cube root of 4x squared raised to the first power. Simplify the radicand, so we have the cube root of 4x squared. Number 3, we have 8a squared b raised to the fourth power, quantity raised to 3 over 2. In radical form, this is the square root of 8a squared b raised to the fourth power raised to, or quantity raised to the third power. Simplifying, remember that if the index is 2, it is no longer written. If there is no index, it is understood that the index is 2. Let us now simplify the radicand. So this means we have the square root of 8 raised to the third power, a raised to 2 times 3, b raised to 4 times 3. Let us simplify. So we have the square root of 8 cubed is equal to 512. So we have 512. A raised to 2 times 3 is 6. B raised to 4 times 3 is 12. So in radical form, the given expression is the square root of 512, a raised to the 6th power, b raised to the 12th power. Another practice, write in exponential form. So this time the given expressions are written in radical form and we are to rewrite them in exponential form. First, we have the cube root of 5 raised to the second power. In exponential form, this is 5 raised to 2/3. Next, we have the fourth root of x cubed. In exponential form, this is x raised to 3/4. And then for the third one, we have the square root of 2x raised to the 6th power, y z raised to the 5th power. So in exponential form, this is quantity 2x raised to the 6th power, y z raised to the 5th power, quantity raised to 1/2. Next, evaluate the following. So for the first one, we have the cube root of 6n raised to the third power. First, we will rewrite this in exponential form. So we're going to have 6n quantity raised to 3 over 3. We know that 3 over 3 is equal to 1. So this is simply equal to 6n. Next, we have the fourth root of 16x raised to the 8th power. Let us first rewrite the radicand or this expression in exponential form. So we have 16x raised to the 8th power, quantity raised to 1/4. Express 16 in exponential form. 16 is the same as 2 raised to the 4th power because 2 times 2 times 2 times 2 is equal to 16. And then we have x raised to the 8th power. So for the 8th power, we have, this is the same as 2 raised to 2 times 4 raised to 1/4. So we will bring out the exponent 4 in each. So we're going to have 2x squared quantity raised to 1/4 times the exponent 4. This is 2x squared raised to 1/4 times 4 is 4 over 4, or simply 1. So which means that the value of the given expression is 2x squared. Let's have the third one. We have the square root of 9x to the 6th power y squared z raised to the 10th power. So we can simply extract the square root of each. You can simply extract the square root of each term in the radicand, since they are all perfect squares. So let's say for 9, the square root of 9 is 3, because 3 squared is equal to 9. The square root of x raised to the 6th power is x cubed. Since x cubed times x cubed is x raised to the 6th power, square root of y squared is y, and the square root of z raised to the 10th power is z raised to the 5th power. So the value of the given expression is simply 3x cubed y z raised to the 5th power. Let's try to have more examples. So here the instruction is write each in radical form. For number 1, 7 raised to 2/3 in radical form, it is the cube root of 7 squared. And 7 squared is equal to 49. So we have the cube root of 49. Number 2, 8 raised to 1/2. That is simply equal to the square root of 8. Next, number 3, we have 3y quantity raised to 2/5. In radical form, that is the 5th root of 3y quantity raised to the 2nd power. Let us simplify the radicand. So we have the 5th root of 3 squared y squared, or the 5th root of 9y squared. Let's have number 4. For number 4, we have 2a squared b cubed quantity raised to 1/3. In radical form, that is the cube root of 2a squared b raised to the 3rd power, or cube root of 2a squared b cubed. Number 5, we have 27 over 64 raised to 1/3. So that is the cube root of 27 over 64. So that's how we write it in radical form. Let's have the next one. Write each expression with rational exponents or exponential form. Number 1, we have the Square root of 5. In exponential form, that is simply 5 raised to 1/2. Number 2. The cube root of y squared in exponential form, that is y raised to 2/3. Number 3. The fifth root of 120 ab raised to the second power, that is quantity 120 ab squared raised to 1/5. Number 4. So we have the nth root of 9xy squared. So that is 9xy squared raised to 1/n. Number 5. We have the fourth root of 14x in exponential form. That is 14x quantity raised to 1/4. So that is how we write expressions from radical form to exponential form. Next, find the indicated roots. Assume that the variables are positive. In this case, we are going to evaluate the given expressions. So number 1, we have the square root of 4a squared b squared. The square root of 4a squared b squared is 2ab. Since 2ab quantity raised to the second power is 4a squared b squared. Next, the square root of x squared y raised to the fourth power. This is now equal to x over y squared. So you extract the square root of the numerator and the denominator. The square root of x squared is x. The square root of y raised to the fourth power is y raised to the second power. Number 3. The square root of 25 over 49. So the square root of 25 is 5. The square root of 49 is 7. So we have 5 over 7. Number 4. Square root of 11 squared. This is the same as the square root of 11 squared is equal to 121. 121 is a perfect square. The square root of 121 is 11. Number 5. We have the square root of 81, a raised to the fourth power, b raised to the 8th power. So we have square root of 81 is 9. Square root of a raised to the fourth power is a squared. Square root of b raised to the 8th power is b raised to the fourth power. So this is 9a squared, b raised to the fourth power. So that is how we write expressions with rational exponents as radicals and vice versa. Thank you very much.